Well, welcome to our hearing today. I'm very grateful for our distinguished panel of witnesses, for those in the audience and my good friends and colleagues on the panel. This is a topic I find incredibly fascinating and absolutely essential to solving our energy consumption and global overheating and ocean acidification problems. We are always going to be, in some fashion, moving ourselves about the planet in vehicles. And the question is, how can we do this in the most energy efficient and environmentally responsible way? And our panelists today can enlighten us on this. I will start with a brief editorial observation that maybe not everyone will agree with, but I find it compelling. And it is that some years ago, the United States, I think, had made some important strides on energy efficient vehicles, particularly the Chevy Corvair. It was a front-wheel drive, high-mileage vehicle, and rather ironically, it was killed by Ralph Nader. And the damage that did to fuel efficiency in this country is immeasurable, and hence the damage it did to the environment, because we labeled small cars, fuel-efficient cars, as unsafe at any speed, and that has been left a legacy of, I think, inefficient vehicles that has contributed to global warming and overheating, and hopefully we can move forward with more responsible efforts to change how we drive and what what our mileage is. Our hearing today deals with DOE's program, and DOE has supported a diverse portfolio of research in vehicle technologies for many years. The goal of the programs is to develop technologies that will maintain the freedom of mobility that vehicles provide while improving our energy security and reducing impacts on the environment. The program sponsors collaborative research on passenger vehicles through the FreedomCar partnership and on heavy-duty trucks through the 21st Century Truck Partnership. While these partnerships have had a number of successes, it's important to recognize when a shift in priorities needs to take place. As stewards of the taxpayers' dollars, it's our responsibility to continually assess these programs and ensure that research activities are relevant to the industry's needs for commercially viable technologies and appropriate to the government's role in exploratory research in areas that industry partners would not be able to pursue on their own. This hearing today should shed light on some of these confusing and sometimes conflicting priorities. Many stakeholders argue that the Vehicle Technology Program at DOE has been a victim of drastic swings in priority between administrations. The Clinton administration sought to develop highly efficient diesel hybrid passenger cars, along with technologies for cleaner and more efficient trucks. The Bush administration chose to focus instead on long-term research in hydrogen passenger vehicles and infrastructure, and to reduce the funding for the heavy-duty truck research. Now, as the new administration develops its own policies, I hope we'll avoid again putting all our eggs in one technology basket. While we must be targeted in our federal R&D programs, a single-minded approach can ignore the importance of balancing a diverse portfolio with sustained funding for long-term research. Last year, the National Academies of Science reviewed both the FreedomCar and the 21st Century Truck programs and made a number of recommendations for programmatic changes, some of which we will hear today. Given the recommendations of these two reports and the constantly changing landscape in the vehicle sector, the committee is interested in hearing the witnesses' views on what the near-term priorities and future directions should be for the Vehicle Technologies Program at DOE. With that, I look forward to working with you all in exploring ways in which federal programs can be improved to support a robust vehicle manufacturing industry and to better serve public needs in advanced passenger vehicles and heavy-duty truck technology development. I now would recognize my distinguished colleague and friend from South Carolina, our ranking member, Mr. Inglis, for his opening statement.
Thank you, Mr. Chairman. Transportation clearly needs innovation. The transportation sector is our primary consumer of oil and is the second largest emitter of carbon dioxide in the country. So the federal government should continue its efforts to provide vehicle technology research and development. Transition from today's dependence to oil to tomorrow's clean energy economy holds enormous potential for our economy, environment, and national security. I'm particularly excited about having our friend Thomas Bloga from Vice President of Engineering from BMW North America. Mr. Chairman, I've got to point out that that's big for us in South Carolina, the fact that we have BMW there. In the upstate of South Carolina, BMW and the International Center for Automotive Research are working together to reinvent the car. with innovation in various things like hydrogen combustion, battery research and development, and it's particularly exciting for us. Should also point out that were it not really for BMW, South Carolina would not have a claim on the transportation innovation future. We're immensely grateful for the $6 billion that BMW has invested in South Carolina, $750 million of which is coming out of the ground right now in an expansion to produce, bring the production of the X3 to Greer, South Carolina, along with the X5 and the brand new X6. So because we have this wonderful blessing of BMW in the upstate of South Carolina, we have a claim to part of the innovation future. And we're particularly excited about partnering in any way we can with the federal government and agencies and others interested in this process to find ways to break this addiction to oil, to truly innovate our way out of our current fix. So thank you again, Mr. Chairman, for holding this hearing. I look forward to hearing our witnesses and how we can continue to develop and encourage a partnership between federal R&D support and the vehicle industry.
Thank you, Mr. Inglis. I appreciate your good words, and we are also have with us Mr. Tonko and Dr. Ehlers. I also want to acknowledge the presence of former Member of Congress Dave McCurdy. Dave, good to see you again, and thank you for being here. With that, I'll introduce the witnesses. Your seating arrangement is slightly different than the order you'll speak, and so I'll introduce you in the order you'll speak, and then we'll proceed. Mr. Stephen Chalk is the Principal Deputy Assistant Secretary for Energy Efficiency and Renewable Energy at the U.S. Department of Energy. Mr. Chalk, glad you're here. I understand you are in some pain from a back injury, so we'll be as accommodating as we possibly can be, and we appreciate very much you being with us. Dr. Catherine Clay, Director of Research at the Alliance of Automobile Manufacturers and a former staff member for this committee. Dr. Clay, it's great to see you again. Thank you for being here. Dr. John Johnson is Presidential Professor of Mechanical Engineering at Michigan Technological University. Dr. Johnson also chaired the National Academy's panel reviewing the 21st Century Truck Partnership. Dr. Ehlers has some affection for Michigan. If he wishes to add any comments, I'd welcome that at this point. Dr. Ehlers?
Well, thank you, Mr. Chairman. I'm very pleased that Dr. Johnson is able to be here. Many people in the lower 48 don't know a great deal about Michigan Technological University, but it's an outstanding university located in the frozen north of Michigan. And I think, you're down to about 4 feet of snow now, probably, about that. It's a great advantage. After they snowshoe to the university in the morning, they're pretty well locked in all day doing research, and they've produced some really tremendous results there. It's an outstanding university, and we're very blessed to have Dr. Johnson with us today, and thank you for being here.
Thank you, Dr. Ehlers. Mr. Anthony Gressler is the Vice President of Government and Industry Relations at Volvo Powertrain North America. He also serves on the Executive Committee of the 21st Century Truck Partnership. And last but by no means least, Mr. Thomas Baloga, who is Vice President of Engineering for BMW, which my friend Mr. Inglis already acknowledged. As our witnesses know, you'll each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you've all completed your spoken testimony, we'll begin with questions, with each member having 5 minutes to question the panel. And again, any colleagues who want to offer comments for the record, those will be accepted. We will start with Mr. Chalk. Mr. Chalk, please proceed.
Thank you, Chairman Baird and Ranking Member Inglis, members of the committee. Thanks for the opportunity to appear before you today to discuss the Department of Energy's vehicle technology program activities. Vehicles are pivotal in meeting some of the most significant challenges our nation faces today, dependence on foreign oil and climate change. The transportation sector accounts for more than 2/3 of our U.S. oil usage. So advances in transportation technology must play a major role in reducing our oil dependence and improving energy security. It's also central to combating global warming, as improvements in efficiency of vehicles and advances in alternative fuels will reduce greenhouse gas emissions. Additionally, vehicle technologies affect consumer pocketbooks. For every 1% improvement we have in fuel economy across the nation's fleet, consumers can save more than 2 billion gallons of fuel annually. DOE's Vehicle Technology Program addresses the nation's petroleum dependency on two fronts: improved efficiency of the vehicles we drive and through fuel substitution, including biofuels, electricity, and hydrogen. The department leads a cooperative effort among energy companies, utilities, and vehicle manufacturers to develop the next generation of automotive technology. Our entire program is reviewed every other year by the National Academy, the National Research Foundation, who give us the recommendations. We work those into the program to improve the program. We've historically had a robust light-duty vehicle program and are evaluating options for innovative programs that recognize the growing importance of heavy-duty vehicles within our budget. Medium and heavy-duty vehicles warrant increased attention because of their growing fuel use, and it's pivotal to the nation's economy. The EIA projects that heavy truck consumption is going to increase 23% between today and 2020, while overall transportation use is forecasted to stay relatively flat. So the influence of heavy-duty vehicles on oil dependence and greenhouse gas emissions is therefore likely to play a greater and greater role. So heavy-duty vehicles are essential also to the well-being of the business community, with 70% of freight tonnage transported by truck. So when diesel prices go up, the trucking industry, many businesses struggle. The additional cost is then passed on to the consumer. So everything we buy, from groceries to appliances to clothing, comes to the store in a truck. So fortunately, the heavy-duty vehicle industry adapts to technological advances relatively quickly. While it might take 15 years for technology to reach a maximum penetration in new cars and light trucks, and you mentioned front-wheel drive, took about that long to penetrate the market, the timetable is closer to about 3 years for the heavy-duty fleet. So this quick adoption of technology of heavy-duty vehicle fleet operators means rapid opportunities for job creation, improved energy security, and lower carbon emissions. Some of the department's successes in the light-duty vehicles can migrate up or over to the heavy-duty sector, such as the batteries we're developing, the power electronics, for hybridization of heavy trucks. In the future, there's a lot of potential for light-duty plug-in hybrid vehicles, or PHEVs, as we might call them. They can stretch a passenger vehicle mileage up to over 100 miles per gallon on a gasoline basis, and displace petroleum by substituting electricity from the grid for gasoline. And since PHEV owners might typically charge their vehicles at night, this would limit the impact to the electrical grid and allow consumers to take advantage of off-peak electricity rates. And a study done by the Pacific Northwest Labs shown that about 70% of our current light-duty vehicle fleet could be replaced with PHEVs without significant impact to the electrical grid. The department's heavy-duty vehicle R&D focuses on advanced combustion and increased engine efficiency, including waste heat recovery, optimizing engines for urban and highway hybrid applications, encouraging the use of renewable diesel fuel, and reducing powertrain losses. The DOE has contributed important advances in heavy-duty engine efficiency. The program had a goal of 42%, or the baseline efficiency, I should say, was about 42% for heavy trucks. We had a stretch goal of 50%, and two of the partners we worked with demonstrated over 47%. So I think there was some success there, although we do recognize the Academy's recommendation to demonstrate that in a full-up heavy-duty vehicle. When the NRC reviewed the partnership last year, they recommended that we do a more systems design approach, and we're taking that under consideration as we replan the program. The next steps towards making significant technological advances will be to look at the system as a whole. So in the heavy-duty vehicle, we'll look at the powertrain, the fuels, the materials, aerodynamics, hybridization, idle reduction. All these capabilities must be engineered together to reach the most efficient vehicle energy balance. So during this period of economic challenge, it's critical that we forge an even stronger R&D alliance with industry to develop the next generation of world-class, clean, efficient vehicles for both personal and commercial transportation. So thank you again for the opportunity to appear before you today, and I'd be happy to answer any questions that you all may have.
Thank you. Mr. Chairman, good morning. My name is Catherine Clay, and I'm the Director of Research for the Alliance of Automobile Manufacturers. The Alliance is a trade association made up of 11 car and light truck manufacturers, including BMW Group, Chrysler LLC, Ford Motor Company, General Motors, Jaguar Land Rover, Mazda, Mercedes-Benz USA, Mitsubishi Motors, Porsche, Toyota, and Volkswagen. On behalf of the member companies of the Alliance, I would like to thank you for giving me the opportunity to speak with you about vehicle technology research supported by the Department of Energy, and for opportunities for this work to serve both public and industry interests in reinventing the automobile. Meeting our national goals of reductions in greenhouse gas emissions and reducing our reliance on foreign oil will require the development of a suite of technologies. Responding to this challenge, automakers are leaders in research and development investment. Total R&D investment by the industry was $79 billion in 2007, up 8% from the previous year. Automakers invest in a diverse array of vehicle technologies. There is no silver bullet or one right answer to what the autos of the future should look like. In the coming decades, the vehicle fleet will likely be much more diverse technologically, with the growing proportions of flex fuel, clean diesel, fuel cell, hydrogen internal combustion engine, hybrid electric, and pure electric vehicles coming into the fleet. Continued improvements to the efficiency of the internal combustion engine will also play a significant role for gasoline vehicles. I would like to begin by identifying general principles that should guide the Department of Energy Vehicle Technology Program to maximize its effectiveness, and then provide recommendations for work on two particular technologies. First, the Department of Energy program should aim to promote technological diversity to the maximum extent feasible, including the vehicle technologies I've mentioned previously. Second, recognizing that each alternative vehicle technology will depend on a well-functioning and available infrastructure, the vehicle technology program should work collaboratively with other departmental divisions on alternative fuels infrastructure challenges. For example, the Transportation Electrification Infrastructure Program, recently included in the Recovery Act, has the potential to significantly advance vehicles like plug-in hybrids. Third, the program should support work that spans the full range of the R&D spectrum, all the way from basic research to commercial deployment. Getting the balance right will be challenging, but no part of the spectrum can be neglected if new technologies are to be brought from the laboratory bench all the way through to the marketplace. Fourth, the department should consider linkages between the Vehicle Technologies Program and government purchasing programs. Acting as early adopters, government fleets can help lead the way to bringing new automotive technologies to market. And finally, the department should develop metrics of success that promote innovative, high-risk, high-reward research. This committee originated the legislation that authorized the Advanced Research Projects Agency for Energy, or ARPA-E, and well knows the importance of emphasizing this type of research. There's an opportunity for the new ARPA-E to cross-pollinate other programs and to encourage the inclusion of more forward-leaning research, despite sometimes lower certainty in their ultimate outcomes. Next, let me highlight two areas of critical importance: the ongoing hydrogen and fuel cell learning demonstration program and the recently established advanced battery manufacturing program. The hydrogen and fuel cell learning demonstration program has included 140 fuel cell vehicles and 20 hydrogen stations, and has worked with automotive and energy company teams including GM and Shell, Chrysler, Daimler, and BP, and Ford and BP. Under this program, vehicles have traveled nearly 2 million miles, and the second-generation vehicles have achieved ranges of up to 254 miles, with fuel economies from 43 to 58 miles per kilogram of hydrogen. This program has demonstrated success both in terms of hydrogen technology advancements and also for the learning demonstration model itself, and should continue to receive support. Last week, President Obama announced up to $1.5 billion in grants to establish a domestic manufacturing base for advanced batteries. A strong, diverse supplier base for advanced batteries will help all automakers move forward to bringing electric powertrain vehicles to market. It is essential that the recipients of this funding have the knowledge and expertise needed to establish battery production at scale. Opportunities for technology transfer through joint ventures with other manufacturers could help establish a domestic advanced battery manufacturing base more quickly. These awards also should emphasize not only the battery manufacturing construction, but also a strong commitment to manufacturing R&D. Without such a strong program element, the manufacturing capacity that we buy with our investment will become outmoded soon after it enters production. We look forward to working with the Department of Energy, and we hope to continue this work to position our industry to be at the cutting edge of the new clean energy economy. Thank you.
Chairman Baird, Ranking Member Inglis, and members of the committee, thank you for the opportunity to provide testimony before your subcommittee. It's a privilege to be here. My key messages for the subcommittee are, number one, please don't pick vehicle technology winners or losers yet. We need an effective palette of solutions that should include an appropriate mix of vehicles powered by highly efficient internal combustion engines, powered by batteries, and powered by hydrogen. Number two, research on batteries for vehicles is a high priority issue. Number three, funding for vehicle onboard storage of hydrogen should continue. Number four, without a developing infrastructure for hydrogen refueling, companies like ours are severely challenged to continue investments into hydrogen-powered vehicles. And lastly, number five, to the extent possible, please allow research funding support for companies like ours that have made huge investments in manufacturing and jobs in the U.S., even though our global headquarters is not located in America. The BMW Group is comprised of Rolls-Royce cars, BMW cars and motorcycles, Mini cars, and Husqvarna motorcycles, and we are the world's largest manufacturer of premium automobiles. In the United States, about 8,000 people work directly for us in our offices, research facilities, and manufacturing plant. We've been a manufacturer in the USA since 1992, and our Spartanburg, South Carolina plant has produced more than 170,000 vehicles in 2008, and we exported about 70% of the total production around the world, and this makes BMW the largest vehicle exporter in the United States. In the year 2000, before many were taking CO2 emissions seriously, BMW management conceived and implemented a company program called Efficient Dynamics to reduce CO2 emissions and improve fuel economy, while at the same time preserving the ultimate driving machine performance our owners have come to expect. So far, we've invested about $1 billion in this Efficient Dynamics program and equipped well over 1 million vehicles worldwide with this technology. A main principle of Efficient Dynamics is that we develop and equip the entire vehicle fleet with improvements as quickly as possible. Rather than focus on one or two models for big improvements, we aim for step-by-step fleet-wide improvements. Our innovations are time-consuming and costly, but they deliver reliable benefits and they trickle down into vehicles that everyone drives. The point I would like to make here is that BMW, as a premium auto manufacturer, as well as other premium auto manufacturers, have invested heavily in technology to improve fuel economy and reduce CO2, and that the low-hanging fruit to get these improvements are gone. Research is vital to advance technology, and working with our suppliers and partners, we develop systems that eventually make their way down to lower-priced cars and light trucks. While the DOE has been a very good stimulator for innovation as far as we're concerned, it would be helpful to us as a heavy investor in the U.S. to be able to apply for and win DOE contracts on our own. Let me give some examples of technology that we're working on with partners to show the positive effect of DOE funding. In a modern internal combustion engine, only about 1/3 of the fossil fuel energy is used to drive the engine crankshaft. That means about 2/3 of the fuel's energy is lost via friction and heat in the exhaust and coolant. Now, hybrid vehicles use methods to recharge the battery when the vehicle's braking or coasting, but not under acceleration. Since BMW is known as the ultimate driving machine, we're also focused on improving efficiency when the vehicle is accelerating and typically wasting significant heat energy from the exhaust. So to recover some of this exhaust heat, BMW has been leading a pioneering effort to bring a thermoelectric generator to market. Now, this system is connected to the vehicle exhaust and uses the difference in temperature of the exhaust and air to create electric current to recharge the battery. So the waste heat is converted into electricity, and this could save perhaps up to 10% in fuel economy. We also have a system called the thermo steamer concept that also can extricate heat from the exhaust. This is more complicated and costly. However, the potential benefits are even greater than the thermoelectric generator. So it would be very helpful, for example, if we could get DOE funding for this turbo steamer project as well. When comparing the technology of hydrogen power versus battery power, the similarities and differences must be considered. A similarity, for example, is that hydrogen is an energy carrier, just like a battery. A battery is charged to store energy, while water is split to make energy available as free hydrogen. A major difference is that hydrogen refueling can be performed in a few minutes, while a battery fast charge today takes several hours. While the electric grid provides limited infrastructure for charging a battery electric vehicle, a far greater infrastructure is needed. Likewise, there's a very limited hydrogen refueling infrastructure, and a far greater hydrogen refueling infrastructure is likewise needed. Today's battery electric vehicle batteries are too large, too heavy, too limited in range, and far too expensive. There can be no debate on the merits of battery research, and we fully support efforts by the DOE to fund battery research. But doing this should not lead to the complete elimination of hydrogen storage funding. That would be very unfortunate. We need both. BMW has partnered with U.S. companies to collaborate on projects involving storage of hydrogen for onboard vehicles, and we see hydrogen as playing an important role in the future as a means to become independent from fossil fuels. And lastly, despite our 30 years of hydrogen-powered vehicle experience, we have an increasingly difficult challenge to justify further investments in hydrogen power without evidence that a hydrogen infrastructure is being developed. And in conclusion, I'd like to repeat the main points of my testimony. Please don't pick vehicle technology winners and users yet. It's too early for that. We need a diversity. Research on batteries for vehicles is certainly a very high priority issue. Funding for onboard storage of hydrogen should continue. And without a developing infrastructure of hydrogen for refueling, we have a difficult time continuing our investment in hydrogen-powered vehicles. And lastly, to the extent possible, please allow research funding for companies like ours that have made investments in manufacturing and jobs in the U.S., even though our global headquarters is not located in America. Thank you for the opportunity to provide testimony, and I'd be pleased to answer any questions.
Thank you, Mr. Beluga. Dr. Johnson.
Chairman Baird and Ranking Member Inglis. My name is John Johnson. I'm a Presidential Professor of Mechanical Engineering at Michigan Technological University. My expertise is in diesel engines, including R&D management. After completing my PhD degree, I spent 2 years as a first lieutenant in the United States Army at the Tank Automotive Center in Warren, Michigan, managing engine research projects. I then worked as a chief engineer of applied engine research at International Harvester, which is now Navistar. In 1970, I came to Michigan Tech. I was chair of the committee that wrote this report in June 2008 on the review of the 21st Century Truck Partnership. The opinions I will give today are my personal ones, although they draw on the findings and recommendations in the report. I'm also a member of the Academy's Committee on Light-Duty Fuel Economy and the Committee on Medium and Heavy-Duty Vehicle Fuel Economy. The Committee on Medium and Heavy-Duty Fuel Economy was formed based on a mandate that NHTSA, under Section 108 of the Energy Independence and Security Act of 2007, enter into an agreement with the National Academies to evaluate medium and heavy-duty truck fuel economy. The Academy report must be completed by March of 2010. The legislation under Section 102 also mandates that NHTSA itself conduct a study on the fuel efficiency of commercial, medium, and heavy-duty on-highway vehicles and work trucks, and 2, mandates that NHTSA then conduct a rulemaking to implement a commercial, medium, and heavy-duty on-highway and work truck fuel efficiency improvement program. Despite the many benefits of the partnership, including helping the engine industry meet the EPA 2007 particulate and 2010 NOx standards, the program suffered from dwindling resources devoted to the program by DOE. Funds were about $87 million in FY 2002 and decreased to $30 million in FY 2008. This funding pattern does not reflect the number of productive R&D opportunities. It also does not reflect the economic weight of the industry. In the 2002 economic census, the truck transportation industry consisted of more than 112,698 separate establishments, with total revenues of $165 billion. These establishments employ 1,437,259 workers who take home an annual payroll of $47 billion. This industry is made up of 10 major truck manufacturers, 10 trailer manufacturers, 18 refuse truck and 5 bus manufacturers, and 6 major engine suppliers, along with over 20 major supplier companies that supply transmissions, cooling system components, turbochargers, brakes, tires, electrical and electronic components, hybrid systems, emission after-treatment systems, and other parts. Because of the low level of funding from DOE, the 21st Century Truck Partnership chose to focus its R&D effort on the Class 8 long-haul type of vehicle, which consumes 75% of the petroleum in the heavy and medium truck sector. It was forced to cancel many projects originally in the 21st Century Truck Roadmap. Federal, state, and local governments and commercial trucking firms, such as utility and delivery operations, that use medium-duty trucks are also interested in fuel economy of their vehicles, since it also affects their operating costs. They want advanced technology, such as hybrid vehicles. In light of the potential fuel economy regulations by NHTSA as required by Section 102 of the Energy Act, it is important that the federal government fund the DOE program at levels such as $200 million per year, with $90 million per year for engine, emission control systems, and biodiesel fuels research. The program should be funded for 5 to 10 years at this level, so that the industry will have the technology in the 2015 to 2020 timeframe to meet potential fuel economy regulations. Safety is an important part of the program, with support in the past from DOE and DOT, with DOT providing the majority of the budget. As crash protection measures have not substantially reduced truck-related highway fatalities during the past decade, the main objective going forward will be to prevent crashes using crash avoidance technologies and in-vehicle communication systems. There is a need for $25 million per year for safety-related research, which should be designated for DOT by line item for the 21st Century Truck Partnership. The next decade needs R&D programs to increase medium and heavy-duty truck petroleum fuel consumption by the use of advanced diesel engine and after-treatment technologies, advanced truck and trailer aerodynamic designs, and low rolling resistant tires. The use of hybrid systems in applications that have duty cycles that can reduce the fuel consumption, including advanced cooling systems and engine components that use less energy, lightweighting of vehicles and trailers so that more payload can be carried, which reduces the fuel consumption in gallons per ton payload miles are needed. A major effort must be carried out to develop biodiesel fuels that meet ASTM specifications, are energy and greenhouse gas efficient in the production of the biocomponent, and make good use of the land without compromising the food supply and the price of the fuel. One of our findings on the management strategy and priority setting pointed out that the program operated as a virtual network of agencies and government labs with an unwieldy structure and budget process. This would be significantly improved if heavy truck funds for EPA, DOE, and DOT were designated by line items that are directed at this program. I know that this is very difficult because each of these agencies go to different congressional committees for their funds. Thank you for giving me the opportunity to discuss with you the 21st Century Truck Partnership, and I also think the partnership would benefit in the future from an external independent review, as was done by the National Academies in their review of the 21st Century Truck Partnership.
Dr. Johnson, thanks for your testimony, and thanks for your role in producing that report. We too rarely thank people who devote so much time to such things, and they're very, very helpful to us. Thank you. We understand that. I'm not sure we all do understand that. Yeah. Yeah, we are grateful on this committee, and thank you very much. And sometimes they aren't even paid for travel. When the Transportation Commission, after the last transportation bill, ran out of funds, they did it on their own money. So, Mr. Gressler. We sure are. Thank you.
Thanks, Chairman Baird, Ranking Member Inglis. Thank you for the opportunity to appear today. I'm Vice President for Government and Industry Relations with Volvo Powertrain North America in Hagerstown, Maryland, in Congressman Bartlett's district. And we're part of Volvo Group North America, which is not cars. Our divisions, our truck divisions here include Mack Truck, Volvo Trucks, and Nissan Diesel truck brands here in the United States. I'm speaking to you today on behalf of the industry representatives of the 21st Century Truck Partnership. 21CTP is uniquely structured to coordinate efforts to improve the efficiency, emissions, and safety of Class 3 to 8 commercial trucks and buses. Our members include original equipment manufacturers, diesel engine manufacturers, major component suppliers, and a number of U.S. government agencies. Member companies are all multinational with major U.S.-based research and development activities. Products from this group of companies consume over 30% of U.S. motor fuel and heavily influence global motor fuel consumption as well. Smaller suppliers can gain access to the 21CTP programs by working through any of the partner companies. Our objective is to assure sustainable, cost-effective freight transport in an environment of limited petroleum supply and carbon emissions constraint. This means we need technology development plus related infrastructure and policy enablers to greatly improve vehicle and freight system efficiency and to develop low-carbon fuel sources. Requirements for heavy-duty vehicles are markedly different from light-duty, and they require unique solutions. Furthermore, the demand for freight movement is directly tied to our economic growth, and it's projected to grow at 2 to 2.5% over the next 20 years per year. In fact, recent DOE projections show that if light-duty fuel use targets are met and heavy-duty trends continue, that heavy-duty fuel use would actually exceed light-duty by 2040. These facts demand a major focus on efficient freight movement, combining strong government and industry efforts. Federal support for commercial truck technology during the past few years has focused mainly on vehicle components and subsystems. This has generated encouraging results in laboratory demonstrations. However, development should now focus on technology that can be effectively deployed in real vehicle applications. We propose a strong emphasis on design for vehicle integration and in-use demonstration. At 42% peak thermal efficiency, heavy-duty diesel engines are already the most efficient mobile energy converters in common use. Through joint R&D programs with the Department of Energy, the industry has already demonstrated the capability of an additional 8 points of improvement in peak thermal efficiency in lab testing. The real challenge, however, is to accomplish this in a truck with emissions, operational, and vehicle constraints, and in a fully representative drive cycle. We strongly support public-private partnership for such a demonstration program. We also need to find ways to achieve 2010 emissions at lower cost and with improved fuel efficiency, requiring a continuing focus on in-cylinder emissions and on exhaust aftertreatment. Hybrid powertrains can offer fuel savings and stop-and-go applications in the range of 30 to 50%. However, the primary reasons to hybridize the Class 8 long-haul vehicle are reduced idle time by using hybrid energy, reduced fuel use through electrification of components, and energy management during traffic-induced speed variation and in rolling terrain. Research and development is required to fully realize the potential of an integrated electric hybrid powertrain. Longer life and less expensive energy storage systems are required. Working with organizations like the Hybrid Truck Users Forum can accelerate technology development, and in fact, discussions are already underway with HTUF regarding future industry forums. At 65 miles per hour, aerodynamic drag is typically more than 50% of the total road load on a heavy truck. Heavy vehicle aerodynamic development has been focused on the tractor, where manufacturers compete vigorously on aerodynamic performance and fuel economy. However, enormous opportunities exist in improving trailer aerodynamics, and further opportunities exist through optimization of the aero performance of the tractor and trailer together offering up to 12% improvement in aerodynamic losses, and further benefits can be realized by aerodynamic trailer treatments if these designs can overcome the issues of durability, cost, and operability. Cost-effective, low-carbon fuels and compatible engines will be necessary, building on work already done in biofuels. In conclusion, the heavy-duty vehicle industry is a small base of companies with a huge impact on petroleum consumption and our economic growth. Despite this, there's been minimal federal investment to address these many opportunities. We believe that $200 million annually in federal funding is required to support these initiatives. The 21st Century Truck Partnership is the only forum in which the relevant companies come together, and we recommend that 21 CTPs serve as the focal point to create a long-term vision for the future of commercial vehicle technology. Thank you.
Thank you all for fascinating testimony, and a number of issues come to mind. I'll recognize myself for 5 minutes first, and then we'll proceed in alternative order, as is our custom here. Mr. Chalk, there's a number of, as we listen to the recommendations of the folks from industry, they offer a number of recommendations and observations. I want to ask you first, what are you doing to take into account, what is the agency doing to take into account the kind of recommendations we've just heard? And then I'll reverse that a little bit and ask the industry, how well do you think that's working, and how can it be made better?
Thank you. A lot of the recommendations you heard this morning came directly from the National Research Council report, which the Department of Energy asked for, and we do this on the automotive and the truck side so that we can make our program better. So in general, we concur with all the recommendations in the report. There is some tension in some areas when we have a small amount of money to work with. You know, if we do a top-down systems approach, that really cuts down on or possibly defrays some of the component level work that we can do that's more of the traditional role of the government to do enabling long-term research. So we try to balance that, but we will incorporate the recommendation to do a system demonstration of the 50% that includes, you know, the after treatment and penalties associated with regenerating the after treatment if it's a particulate filter, all the other system recommendations that were incorporated, and try to do that demonstration and prove that that is in fact possible, which is a significant accomplishment of the program to go from 42 to 50%. We're also reconsidering the budget there. We have opportunity on the Recovery Act. DOE has discretionary funding, so we'll relook at the heavy duty to make sure that our budget is commensurate with the problems to be solved in terms of oil dependence and climate change, and that can be done in a time frame that matters in terms of addressing those issues. So, and we have opportunity, of course, now in formulating our FY10 budget to make those adjustments as well and consider the NRC recommendations. The swing has been there because, as mentioned, you know, light-duty highway vehicles are 3 times heavy duty. So we really focused on the lion's share of the problem, so to speak. But as I said in my testimony, the trends are, and it's been mentioned here, that while light duty is flat, and we can maybe decrease that a lot if we make good gains there, the heavy duty is actually increasing. So we have to look at that and see what gains can be made. And I think that systems analysis will help us do that. We'll know how much more we can get out of thermal efficiency of the engine, how much more we can get at aerodynamics, auxiliary power.
Okay, thank you. A couple of issues I heard that I want to make sure we have a chance to elaborate on. I appreciate the input. Yeah. One is this issue of private partnership. Mr. Beloga, you mentioned it. I think Dr. Clay and others may have mentioned it. The ability of private entities. Mr. Beloga, talk to us a little bit about that. It sounded like you're saying you'd like the ability, you've got some expertise in your firm, you'd like the ability to compete for some grants. Is it your experience that that's precluded, or that basically is all the research being done in-house and not as collaborative as you'd like to see it? Or
Well, what we would like to be able to do is bid on contracts for cooperative research on our own. Right now, we do that with partners, and the DOE has been very accommodating to different projects. However, we need to partner with someone who is themselves able to apply for the contract, and that puts limitations.
Is that because of domestic versus international ownership?
Yes.
That's the issue, okay.
Yes.
And I think Mr. Inglis is going to follow up on that a little bit,
Right.
so. There is going to be a fair bit of money in the stimulus package, and I'm going to ask each of you, if you could invest that money, how would you invest it? Dr. Johnson? I'll just work my way. I mean, I'm going to ask you to do this not just in the interest of your own industry, but in the interest of the country. So if you, looking objectively, what would you do?
The truck component is extremely important, and as I mentioned in my testimony, the industry is very diverse, and they're not as politically visible as the automotive industry, the car and light truck. And diesel engine technology is really important. That's the heart of the truck. Diesel engines are most efficient, as Tony mentioned. And hybrids are very important too, and I think they need further stimulus. There's a lot of difficulty with the batteries and storage, as Tony talked about, because of these larger vehicles, and they need more different storage capacity maybe than a plug-in hybrid. So,
Mr. Kressler?
Yeah, thank you. First of all, we strongly support the idea of integrating technologies. We think that that's one of the core things that has been lacking in the previous programs is to make sure the whole technology package works together in a vehicle and meets emissions as well as the operational requirements in a real duty cycle. And we greatly appreciate the new emphasis that DOE is now placing on that. As far as specific technologies, there continue to be need for more in-cylinder combustion work. Certainly, waste heat recovery, which Mr. Beluga mentioned, but that's we're well on the way with waste heat recovery evaluations in heavy duty. But again, it's difficult to integrate that into a truck with the cooling requirements, so we have to be careful. Hybridization, and in particular, long-haul hybridization, which will be a different kind of a technology than what you see in light duty, because it's not so much stop and go. It's more dealing with managing the duty cycle and the energy use in the vehicle. And we need different kinds of batteries. We need particularly high energy capability because we have to restore and utilize energy at a very high rate. So that's one of the big factors that we deal with. So there are specific areas that we think make a lot of sense there. Thank you.
Dr. Clay?
I'd like to speak to the portion of the stimulus that recognizes the importance of science investment. There's tremendous funding provided in the Recovery Act for increases in science investment, and I think there are opportunities for powerful breakthroughs that we can direct some of that science funding to the so-called Pasteur's quadrant, where we're looking at use-driven science. So I think in this particular area with vehicle technologies, there are tremendous opportunities and very exciting ways we could apply that. So potential breakthrough game changers that we could use that kind of science funding and linkages between the science and the applied energy programs like the Vehicle Technologies Program could include things like combustion research, where we would be able to use our tremendous user facilities at our national laboratories for breakthroughs in optimizing combustion research, and also things like the advances in material science and nanotechnology to revisit some of the battery technologies that the Department of Energy previously supported in past decades but hit roadblocks. And with 20 years of advances in material science and nanotechnology, I think it would be very exciting to use some of that funding to revisit those chemistries and to see if some of those roadblocks might now be able to be overcome.
Thank you. My time has expired now. I'll recognize my colleague. I want to also acknowledge the presence of Mr. Davis, Ms. Edwards, and Ms. Woolsey, who've joined us as well. And I see Mr. Bilbray is here and Mr. Bartlett as well. Dr. Bartlett, good to see you as well. Mr. Inglis.
Thank you, Mr. Chair. Mr. Beluga, it's impressive that I learned this morning that 70% of the production from the Spartanburg facility is export bound. It's also tremendously impressive that there are 5,000 employees, so about 5,000 at the Spartanburg plant, 17,000 employees in the supplier network in the region. So it's consistent with what you're saying about the importance of not disfavoring an international company in research projects. Might you describe some of those impediments so that we could understand better what we could do to remove those impediments? Because obviously, for South Carolina, which is now the #2 unemployment state in the country, and the place where your plant is actually higher unemployment than the state average, were it not for BMW, we'd be in a world of hurt more than we're hurting now.
Well, thank you, Mr. Inglis. We certainly have a lot of innovation to offer, and as a premium manufacturer, obviously we can charge a higher price for technology, and that's really where breakthroughs take place. If you look at going all the way back in safety technology or emissions technology, the premium segment of the auto industry is where the major breakthroughs occur because of the funding aspect of it to pay for this technology. So we really have a lot to offer. If we develop it on our own, then we put it in our vehicles and it eventually trickles down into the mainstream. Whereas by partnering with companies in the US, we're able to get DOE funding and other government funding contracts for this technology. And eventually it makes its way into production and is widespread throughout the industry. But if we could get the funding directly, we would be able to more quickly get this innovation into the mainstream and into production. What happens is there's actually a delay. We have to pick an appropriate partner. We have to go through the process, make sure the partner's correct, make sure we have all of the I's dotted and T's crossed. And this investment of resources really slows down the whole project. So if there was a way that we could directly bid for contracts and so forth. Now, of course, the innovation that comes out of that is property of the contract, and it is available. There are no secrets when it is a government contract. So this information gets shared very quickly. So I would say that by enabling this to happen with a company like ours that has made a huge investment and just so happens to have a global headquarters outside the U.S., this would actually bring the technology faster to the forefront, bring it faster into the mainstream vehicles, and that's something we would like to happen.
You know, it's interesting, you mentioned that the premium vehicles have been the ones that have caused the breakthroughs, which makes sense. I hadn't thought about it until you said it, but it makes sense because there's some opportunity to improve and a customer who's maybe willing to pay for that improvement.
Exactly.
By analogy, something this committee is getting used to hearing from me is, you know, as long as the externalities aren't attached to the price of gasoline, it's the same thing, right? I mean, if we're right on this margin with an unrecognized externalities associated with gasoline, if you recognized them and attach those, internalize those externals, then suddenly the economics change. And everybody sort of becomes more of a premium manufacturer at that point, because then you're saying, oh, this stuff is pretty expensive, this gasoline. When you attach the national security cost, for example, to it, then suddenly all kinds of innovation starts becoming possible. A little bit like the premium brand. I hadn't really thought about that. That's a helpful thing this morning. Somebody tell me how we avoid picking winners and losers. Anytime we fund something, we're sort of picking a winner. So, for example, Dr. Clay didn't like it very much, but the H prize we tried to do, that was an attempt for us to fund something. It favors hydrogen over something else. How do you avoid doing that? Anybody got any suggestion about how to avoid winners and losers? Yeah, Dr. Clay.
Thank you, Congressman. I wanted to say, thank you for mentioning the H prize. I wanted to say, the Alliance supports a diverse array of technologies, and I think it's to the interest of the country and the industry to have as many innovative tools in the toolbox as we can to try to get that kind of research. And the beauty of the prize authority as a general tool is that it's able to leverage a tremendous amount of private investment, and it allows a breadth of entrants and ideas that you can't get through a formal RFP process. So, I do want to say that I, personally and in my former capacity, supported the goal of the H Prize and supported the idea of hydrogen technology. Our fear at the time was that by making it so specific to hydrogen that we might actually inadvertently discourage using that prize authority for other programs. I think that with the new administration and the comments that Secretary Chu made before this committee, that's no longer a concern, that the idea of using innovative ideas like prize authority is something that will become internalized to the Department of Energy going forward. And so just hopeful that we will see a successful H Prize going forward.
Yeah, and maybe later, another round, we can talk about just how do you avoid this winners and losers things. I don't know how you do it other than an elegant price signal. If you send a price signal through the economy, then you don't have to worry about picking winners and losers. We'll come back to that, Mr. Chairman.
Thank you, Mr. Inglis. I would just say I think based on what we know about global overheating and ocean acidification, I think we have to pick some losers. The losers are those that pollute the planet. The winners are those that pollute less. And we do need to pick some losers at the very least. And I would say fossil fuel-based consumption at some point has to be a loser in favor of things that don't create climate overheating and acidify the ocean and kill this planet. So, Mr. Tonko.
Ms. Clay, Dr. Clay, the investment in R&D that you cited was, I think, year 2006 to 7 was an increase of 8%. Can you chart that since 7 forward? Is it as strong an increase?
Congressman, those numbers are reported to the National Science Foundation that does a compilation. I believe the numbers for 2008 are not yet compiled. I think it's difficult to say, given the economic downturn, whether the industry is, I simply don't know the answer to whether the industry maintained that funding level. I can say that the industry is as committed philosophically going forward to developing advanced technologies. And so given the availability of resources, that you will see that level or that level of commitment going forward from the industry.
And can we track it backward from 06 to 96? Was there a steep curve of R&D investment?
Congressman, I'm not certain what the trend is, and I'd be happy to find that out and give you that information.
It seems to me that the secret here to get an energy-efficient vehicle, be it our cars or our trucking industry, in sync with what consumers now want, we need to ramp up significantly the R&D investment. And I would ask, is your interpretations of where the weakness might lie? Is it with industry or government infusion of R&D investment?
I think actually this ties nicely back to, unfortunately Congressman Inglis had to step out, but I think that this ties nicely back into his point about market signals. I think that one of the main drivers for investment in advanced technology is a certainty that technology has a reasonable chance of competing with the entrenched technologies. So with the volatility of gas prices that we've seen, it's difficult for investors or would-be investors in things like advanced biofuels or in battery technology. It's difficult for them to run the numbers forward and know whether their investments are likely to pay off with marketable vehicles. If we had greater certainty in gasoline prices, if we knew that they were to stay, let's say, above the $4 mark that we hit last summer, that would send a very strong signal to the investment community that these alternative fuel vehicle technologies would find acceptance in the marketplace. And so one policy option for driving technologies into the marketplace is to provide those strong market signals.
Is it just a function, though, of gasoline prices, or is it a function of cleaning the environment?
Well, I believe that the way that you can get to that goal of cleaning the environment is by driving the market signals, because anything that you do to drive the market signals for petroleum will encourage consumers to buy more fuel-efficient vehicles. And so as a secondary effect, you will inextricably be able to deliver better greenhouse gas profiles per mile, and also other associated emissions would also go down.
It seems to me with some of the investments made in foreign produced, it would trigger some sort of indicator to the investor market. It seems like we're falling behind as an industry because we haven't kept pace with the sort of vehicle that Americans would love to purchase. And if I could just flip to the battery discussion for both you and Mr. Chalk, how important is it for us to create diversity within that focus?
When you say diversity within the focus, you mean within the lithium-ion family?
Well,
Or
within
other-
the battery discussion itself, should we put all our eggs in that one technology basket, as I heard mention of earlier, you know, as an expression, or should we look at other forms of battery technology that might be more suitable to bigger vehicles, or to the car fleets, the auto fleets? Should there be something beyond lithium-ion that we look at?
Well, I would say yes, and we always survey the latest chemistries and batteries. But I would say within the lithium-ion family, there's a bunch of diverse electrolytes and cathodes and things like that. So it's not just, you know, one manufacturer will have a totally different chemistry than another manufacturer, even though they both may be classified as lithium-ion. So there's lots of different types within the lithium-ion family. In general, though, whether we're talking about power generation or vehicles, we have a very diverse portfolio that, you know, the magnitude of the problem is such we have to have hydrogen and biofuels and electricity. Go ahead, sir.
No, if I might just ask, because my time is running short, with the stimulus money, with the Recovery Act money, are we going to look beyond lithium-ion? Are we going to look at battery technology that takes us beyond that?
What we're saying is and the President last week announced the $2 billion that was in the Recovery Act for manufacturing batteries. And basically what we're saying is those batteries coming off of those lines have to be compatible with a plug-in hybrid electric vehicle. The chemistries and things like that are up to the proposer if they can meet those requirements.
Dr. Clay, any comments on the battery?
Yes, I think one important point is that when we speak about hybrid vehicles, that the realization should be first that hybrid vehicles are in fact a suite of technologies themselves. So a lot of our discussion tends to focus on plug-in hybrids, and that's a very exciting technology and should receive discussion. There are a range, though, of possible hybrid configurations going from vehicles like the Toyota Prius that's a full hybrid but has a smaller battery pack than something like the GM Volt that's been announced. And then pushing further back, you can have an even smaller battery pack where you have what's called a stop-start hybrid with a very small battery that's able to reclaim regenerative braking and deliver significant fuel economy benefits. So because there is a range of hybridization possible, that hybrids themselves are not a single technology, we need to be thinking about a range of battery chemistries that are suited to each of those niches along the way. And so I think if we start conceptualizing hybrids as a continuum, then we will naturally start looking at investments in battery technologies along a continuum, and that will naturally bring us to looking at a diversity of battery chemistries.
Okay. So can we hope that the Recovery Act stimulus money can accomplish that broader view?
We are looking at it. I want to emphasize, though, that there's nothing that has the power density and the energy density than the lithium ion. So, you know, at one point we want diversity, but we also want critical mass, because if we're going to address these problems, we eventually have to build something so that we do have to down select and pick some winners, so to speak, and go with our best shot. But all the time we're looking at what's the latest coming out of small innovative companies or out of our national laboratories to see if something better coming along that can meet those requirements.
Thank you.
Mr. Ehlers, Dr. Ehlers.
Thank you, Mr. Chairman, and thank our guests for the testimony. It's very stimulating and very useful. That's not always true around here, but I do appreciate it. Just a couple of minor comments first. I appreciate Mr. Gretzler bringing up the issue of trailer design. I've often wondered why no one has worked on aerodynamic trailers. I have a personal interest in this. I used to drive a truck, a semi-trailer and tractor, and it was pretty primitive back then, no consideration. I was pleased to see the cabs at least showing some improvement, but there's so much more that could be done there in a lot of ways. In all the discussion about batteries, first of all, batteries have been the problem for at least 50 years. I have a good friend who's a physical chemist who's been working on batteries for at least that long. A very, very complex issue and not easily resolved. It's not just a matter of saying, well, we're going to do some research and we're going to have wonderful batteries. It's far more complex than that, and we should all recognize that. One interesting sidelight, since I enjoy flying, there's a lot of discussion now of electric airplanes, which would be used only for recreational purposes. But this in itself would be very helpful in terms of petroleum use, air cleanliness, and so forth. And so there are a lot of other uses for good batteries than in automobiles. In terms of the hydrogen, I've been skeptical about that for a considerable amount of time. The infrastructure problem is, as far as I can tell, not being addressed. Every time I raise the issue, everyone says, yes, yeah, that has to be addressed, and we'll do it, but they all have different ideas. Absolutely, all the infrastructure involved is incredibly complex. You'll need new means of carrying the fuel, transporting the fuel to distribution centers, getting it into the vehicles. It's not an easy problem at all. And I'm not opposed to the use of hydrogen fuel cells. I think it'd be wonderful. But we have immense problems to overcome there if we're really going to do that large scale. And the infrastructure, I think, is going to be very difficult. One quick comment about federal investment. Roughly a decade ago, the Department of Energy cooperated with the big three on a research project. I don't remember the name of it, but it was under the Clinton administration. We were going to produce a vehicle that would do 100 miles on a gallon. And many of my colleagues were very skeptical about it and didn't support it. I was skeptical, but I thought, let's give it a try. As far as I know, nothing ever came out of that. And that's increased my skepticism of the federal government working with the automobile companies. Can they, in fact, put aside their own personal interests and work in a cooperative way on research with the federal government? I don't know. I hope so. But the evidence there hasn't been there so far. I appreciate Mr. Bologna's comments about the heat recovery. Immense amounts of heat lost and generated by automobiles, and anything you can do to recover that is bound to be good. And I certainly encourage further investigation of that. That's a wide open field with lots of possibilities. Once again, not easy, but it can be done, and easier than many of the other alternatives. I don't have any particular questions because you've all been so thorough in your comments, but I am pleased to see the Department of Energy taking a substantial interest in this issue, and I hope that we can develop good cooperative working relationships. It's just from every aspect you look at, the environmental, the foreign policy issues of our dependence on oil, everywhere you look, this is one of our biggest problems today, and we really have to address it in a very strong, uniform fashion. And I think this hearing is helping us see that and also bringing out the ideas you have of doing that. So I just want to thank you very much for your comments and the ideas you've presented. Thank you.
Thank you, Dr. Ehlers. Ms. Woolsey.
Thank you, Mr. Chairman, and thank you to the witnesses. Mr. Beloga, you, in your testimony, say that to any extent possible, research funding to support companies come go to global industries not located in the United States. Tell me, and this is in total innocence that I ask this. I have nothing here that's trying to set you up or anything. Tell me how in Great Britain with BMW, how would those investments come to the United States? I mean, where's the real partnership here? I mean, is there one? How do we ensure that if the United States invests in partnership with BMW, that the jobs stay in the United States? I mean, we are hurting for jobs. So is there, I mean, the subsidies that BMW gets from Europe or the European Union or from Great Britain, do those come to the United States? Can we bid for them over there?
Well, I guess let me answer the question like this.
Okay.
The technology that is developed as a result of these cooperative packages and contracts makes its way into the hands of the American public in the way of better performing vehicles on the road.
I understand that, and I believe in that totally. I'm talking about jobs. I mean, we won't have people that can afford to buy the cars that if we don't have people working here in our country.
Right.
So how do we keep that money, if BMW benefits, yes, we'll benefit in the big picture. How do we keep, is there a way to bring that, ensure that money stays in the United States for jobs?
Well, the research on the projects would be for the cars, the vehicles built in this country, and of course, if the research project is for something that would be making more efficient manufacturing, certainly that would be directly resulting in jobs in the U.S., and that would be tied to our plant, for example, Spartanburg, that we're expanding by 50%. I think to answer your question, perhaps the best way to go about it would be to think of it in terms of an investment in a company that is going to be favorable to the market, that is being its friend. We all tend to be more amenable to friends. There's a saying that says, keep your friends close and your enemies closer. There's a good reason for that. Not that we want to speak about this in terms of friends and enemies, but when there is an investment in this country by our company, there is a certain closeness, a rapport that's established. The great people of South Carolina have made the success down there with the plant. That's the reason we stay here and expand, because it has been so successful. So I think the success...
Well, thank you. Okay, I get all that. I just want to make sure the jobs stay here, too. So I appreciate that. I do have an open question for anybody on the panel. Are there promising technologies that aren't as far along as plug-in hybrids and hydrogen, that with a big push may be more promising in the long run? Yes, Mr. Guy. Yes.
Yeah, I would say absolutely there are, and we mentioned one, which was waste heat recovery. There are multiple techniques for waste heat recovery. We're looking at Rankine, basically steam type cycle, which Mr. Beluga mentioned. We're also looking at thermoelectrics. There are some advanced work with things like thermal acoustics. All of these techniques have some promise of taking energy used or wasted in the exhaust stream and recovering it to produce useful energy, for example. None of them are really at a point where they're truly effective in a vehicle. And there are a variety of reasons for that: efficiencies in some cases of the materials, the cooling system requirements, how we package it within a vehicle, the heat exchangers, and the efficiencies all need to be worked on to make them truly effective. But there are a lot of opportunities there. As far as something that's really not, closely available, but something that could be made available in the near future with the right focus.
Well, should we be focusing on those technologies along with, side by side, or do we have to give up? Should we only be investing in the farther along technologies and let the others come along as they can?
Personally, I think we need to do some of both, but we certainly need to be moving technologies into production and into the marketplace, or we accomplish nothing. But if we don't keep a focus on advanced technologies that require more research, then we have nothing in the future. So somehow we have to manage both of those.
Thank you very much. Thank you, Mr. Chairman.
Ms. Woolsey, thank you. I very much appreciate your line of questioning about American jobs because it's so central to all of our districts. Before you arrived, Mr. Inglis commented as representative of the great state of South Carolina, the impact of BMW. I'm going to recognize him for about 20 seconds before I turn to Mr. Bilbray.
Yeah, thank you, Mr. Chairman. Ms. Woolsey, you might have missed earlier that BMW, a German company, has invested $6 billion in South Carolina. And the numbers I gave earlier of about 5,000 jobs in South Carolina, 17,000 in the region, actually are low when you consider the U.S. The total U.S. number is apparently about 50,000 jobs because BMW is here making and selling cars. It's an incredible benefit of international trade. Thank you.
Thank you, Mr. Inglis. Mr. Bilbray.
Thank you, Mr. Chairman. And I'd also like to point out that American car manufacturers produce jobs overseas, Canada, Mexico, Australia. So there's no guarantees. Mr. Chairman, I apologize first. I want to point out, make sure we remember the context in which we're discussing here. We're talking mobile sources. And we're talking about total emissions in this country is 28%. And so as we think about this, we think about plug-ins. We're thinking about the creation of hydrogen. We also got to remember that 35% of the emissions total in this country are from one source, and that's electric generation. So we're talking about 28 today, but we've got 35% out there that's going to be related to this, addressing the 28. And remember that electric generation is the most clean, or the biggest user of zero-emission generation. They produce power, I think it's 22% of all electric generation is done with technology that has zero emissions. So I bring this up because it's important as we talk about the line that if we do not address that 35%, which actually historically is used the cleanest, the most zero-emission generation, we're never going to get a climate change strategy that works. And so as we talk about mobile, remember, this is a smaller version. It's not going to be the major. We need to still address that. And so as we talk about plugging in our hybrids, when we talk about generating hydrogen, we've got to remember we still come back to the elephant in the closet, and that is the fact that if we don't go to zero-emission generation for our electricity, everything we're doing in mobile is a lost leader. Speaking of that, and oh, by the way, if you want to talk about mileage and fuel consumption, if we eliminated all of the obstruction that local government does with inappropriate traffic control, we could probably do more savings and more reduction. It was estimated that 95% of all stop signs could be yield signs. Stop signs 5 times more polluting than not having and uses up fuel. But that's for another hearing. I think the one I'd like to say here is we talk about different strategies, and I guess it's Mr. Chalk, the issue of the CAFE standard. I've got a question here. Historically, our CAFE standards have always been based on a 100% gasoline mixture, right? Okay, now.
With biofuels credits and things like that, yes.
Well, no, and I'm talking about the standard itself. Now, do we include the reduction in mileage because of the 30% less fuel efficiency of something like alcohol, ethanol, when we're reformulating this fuel efficiency standards? Because the old standards that we developed in the 70s and the 80s, which I strongly supported extending over a period of time, have we modified now what those standards are, considering the fact that now it is mandated that we use 10% alcohol in all fuel sold in the United States, and thus the mileage, the practical mileage has dropped? What are we using? Are we using a new formula based on the fact that ethanol is there, or are we still operating off the concept, at least the standard, of 100% gasoline?
I don't know the answer to that question. NHTSA, the Department of Transportation, issues the rules. You know, the CAFE is to increase fuel economy by 35% by 2020. I don't know if they made that adjustment for what we would call gasoline equivalent, but that seems like the right thing to do.
I think we darn well ought to have it somewhere, because we either have to understand that we can't increase the mileage as we are mandating that the fuel mixture have less energy capabilities in it. And we've got to reflect that. And I know it's a catch-22. I come from the Air Resources Board in California, and these catch-22s show up all the time. But here's the thing, well, what are we doing in government on this?
Well, I just add there's so many other factors that would affect those miles per gallon rather than the fuel use. So it may, in the wash, it may come out not to be a relatively minor effect, even though the 10% of that fuel might have 30% less energy in it.
And you know, especially at a time that the ethanol industry's pressuring EPA to allow more fuel into the mixture, even though we know there's environmental and technical problems there.
Well, the renewable fuel standard would actually add a lot. It would add $36 billion by 2022.
I'm not talking about. I'm talking about the percentage of percentage of ethanol inside the gasoline we're required to buy in this country.
Right, but to get the 36 billion gallons, we would have to have probably a higher blend than 10% to get there. That's the best way to get that 36 billion gallons out in the infrastructure would likely be by increasing the content of the alternative fuel in a gallon of gasoline rather than have pure ethanol or something like that at the pump.
But it can't be ethanol unless we have a major modification in the vehicles themselves, because we knew this in '92 that ethanol was going to create destruction of the equipment, the seals, and cause emissions problems. And now we can't put more ethanol in the fuel, so we have to go in on another kind of renewable to be able to increase the standard.
Well, actually, we can. We know how to do it. It's relatively minor cost to the vehicle, less than $200 by most studies. We can make things compatible, and there's fuel flex. There's many fuel flex vehicles out there, so it is an adjustment that can be made. We have the know-how. The car companies know how to do that, to go to higher blends of ethanol.
Well, I would appreciate looking at that, because at ARB, they are still very concerned. In fact, let me point out, Mr. Chairman, ARB just this month came out with a study showing that ethanol has the air emissions benefit of regular gasoline. It is no more than what we've had before.
Let me try to enlighten you a little bit on that. We can do it in terms of compatibility. The car companies know how to tune the engines. There's an evaporative emissions issue in California.
Big issue.
And that's really, it has to be re-engineered around so that when you put more and more ethanol, you get higher vapor pressures in a gallon of gasoline. You have to make sure that that evaporative emissions is captured.
Well, Ms. Chalk, why is ethanol given a $1 tax credit by that other biofuels are not allowed? Why is ethanol specifically chosen as a winner in our tax codes?
Congress has decided that it's not $1, or it may be changed, but it was 54 cents. I don't know if the latest farm bill changed it or not. Possibly, could be wrong there. But so it's a policy, I think, driven from the farm subsidies.
So in other words, we've chosen a winner here, and that is ethanol gets a subsidy, but other biofuels like algae fuel does not get the same subsidy.
If it was turned into ethanol, it would.
Okay. You know, Mr. Chairman, let me just tell you something. That is exactly the problem. Ethanol is, I'll still go over the fact that it is a loss leader. We're putting massive amounts of money thinking someday a better fuel will show up. At the same time, we're not given the same benefits to alternatives. And that's the kind of thing of picking winners and losers. And obviously, I understand this when the farm lobby shows up, when people come over and start talking. But I think that when we talk about fuel efficiency, and we're talking about the big picture, here's a place where we pick winners and losers. And
Mr. Bilbray,
I appreciate that, Mr. Chairman.
I concur with you. I think, however, the best witness for this would be POGO, not our colleagues here, because we've seen the enemy and he is us. And I think it may have something, the answer to your question may have something to do with the primary structure of presidential races more than energy efficiency. I would be, Mr. Davis is next.
Mr. Chairman, thank you very much, and Ranking Member for having this hearing this morning. I live in rural America. I have a congressional district that has 10,000 square miles, 63 people for each square mile lives in that congressional district. We have very low-income individuals. We're excited about the fact that maybe we can have an automobile that will go someplace as quick as a combustion engine, much cheaper and less polluting. We hope that's in the future. We really want to see that happen. As a young fellow, I bought a 77 model diesel automobile. I won't mention the name of it, but it got 50 miles to the gallon in 1977. If I'm not wrong, that's about 30-some years ago. I doubt that you can find an automobile that's built in America today, and that one was, that will get 50 miles per gallon. What's happened? And so I asked that question for a reason. I know as we engage in lessening our carbon footprint, we have to look at new technology as well as old technology. I'm not sure what happened to those automobiles, and I'm not sure that one's still around, but I'm not sure why we're not able, 30-some years later, with all the money we've spent on being able to find energy-efficient automobiles, with the effort that we've had for many, many years to look at, as we do research on the South Pole and we see the carbon content continue to escalate, and as our climate starts changing, now I've heard on this committee some folks say climate change is not happening, that's just a national phenomena, and that global warming is not happening, that's just something that normally happens throughout the eons. It reminded me when I heard someone say the other day of a fellow that was working with Galileo, and he said, why do we study the stars? They all look the same to me. So I guess in my, not necessarily a question, but a statement I want to make, I know as we go through this research of trying to find alternatives to fossil fuels, or at least to be able, if we're going to use fossil fuels, to make those automobiles more efficient. Maybe we should go back to some of the old technology we've already had. Maybe we ought to start renewing some of those. So my challenge to you, as we spend taxpayer dollars on research and development, for goodness sakes, let's don't see huge vacated industrial sites like some in my district that was an ethanol plant that's rusting down, that was built in the late 70s and early 80s, that is no longer being used. You're the scientist. You're the ones who are asking for the dollars. We're the ones who are giving you the dollars and demanding that you do some research to give our planet and the American consumer and the world some relief. I look at Europe, who've been charging over $5 a gallon for gasoline for the last 2 decades. And if the cost requires you to find more efficiency, obviously they've got a smaller car and smaller horsepower and smaller engines. I don't know how much better mileage they get than we do here. When I look at the population in Europe and the population in America, they use about 3/4 as much fossil fuels as we do. Of course, they got a little bit harsher climate, so maybe they use that for heating. So as we engage, Dr. Clay and Mr. Chalk, you folks are kind of overseeing these dollars, I guess, that we're kind of shoveling out there with a scoop, like a barn scoop. Let's be sure that we're getting our money's worth. If we look at technology and it's going to be battery-driven, if it's going to be driven by a hydrogen automobile, whatever it may be, utilize America's taxpayers' dollars wisely this time. And I do believe that research and development makes a difference. My father told me 50 years ago, maybe longer than that, someday there will be a small pill that you'll put inside a reactor in an automobile. It will be a little nuclear energy that you can put, and it'll drive you for the entire life of that automobile. Maybe that's possible. I don't know. There's some folks on this committee probably wouldn't agree that ought to be used, or some environmental group may not. But I just think as we look at research, it all needs to be included and not just a part of it. That's basically a comment from me. Help us. That's what you're here for. Asking you to help us is why I'm here.
Anyone wish to comment on the comment?
Well, I would just say that we have a diversity of portfolios, and we're very serious about making progress in this area. You know, of course, we lose our grip sometimes when energy prices go back down, and I think history's shown that. And I think what we have to do is maintain the focus, even though compared to last year when gasoline was $4 a gallon and people were really worried, now that it's gone down a little bit, there might be a tendency to relax. We've got to stay focused on what we're doing and make this work.
Dr. Johnson?
Let me try to answer your question. The diesels today produce much lower emissions, significantly more, and there's a significant cost with these after-treatment systems. And the people like BMW and VW, because they've developed diesel engines in Europe in the light duty, they're starting to bring them over to the United States. One of the problems in the last few years has been that diesel fuel is 60 to 70 cents a gallon more because of the market demand. And so the whole problem that we've been discussing here is the price of fuel fluctuates. And I really didn't come to testify about that. But I think we need a tax on fuel so that we get a floor of about $2 over 5 years, and then be neutral and give this tax back to individuals and back to industry so it's neutral, not just a tax. That will help drive the market, and that's what's true in Europe. They have a fuel tax. They've had it. They've got about 50% diesels. They've got smaller vehicles, and it's a natural market phenomenon. And the problem with CAFE is that the market price of fuel goes up to $4 and then back down to $1.80 or $1.90, and it just changes the whole thing. And you cannot change the manufacturing plants and the product development schedules to meet that, and that's really the problem, So.
Sure. I know I'm imposing on the time frame we have here, and Mr. Chairman, I thank you for allowing me. I've also heard that through integrating into the actual structure of an automobile, natural gas, a capacity where you could get at least 250, maybe 300 miles on a compressed natural gas capacity, if it's integrated into the system of an automobile, 80% less carbon emissions, supposedly, with natural gas. Why are we not looking at that until we at least find that bridge, until we bridge to that next energy source, whether it be batteries or whether it be hydrogen or whatever it may be? Is there research on that now, and is that possible even to convert automobiles today to a natural gas system, which is more clean, efficient burning?
I'm really not expert in that, but people are working on. But again, one of the problems are that cars live for 15 years, diesel vehicles live for 30 years, and the infrastructure for the fuel and the distribution is always a problem. Just like the flex fuel vehicles, there just isn't any fuel out there. It's been given a credit for the 85%.
But every home has natural gas just about, and very easy to hook up to it. And almost every service station in America has a natural gas heating system. I'm not saying it, but many, I think that is available. I think it's an area where we have to look at least as a bridge fuel until we get to that new source or whatever it may be.
I think Honda has looked at that and are looking at it, and other companies probably will.
You can buy a Honda vehicle that gets a 170-mile range that's natural gas.
Dr. Bartlett.
Thank you very much. In armed services, we don't have earmarks. We have plus-ups, and they are fundamentally different. Mr. Gressler, it's been my privilege for the past several years to be the proud author of a multi-year series of plus-ups for Volvo Powertrain, Mack Truck in my district, and I want to thank you very much for your aggressiveness in developing a really good hybrid truck for the Air Force. There are 3 reasons for looking at alternatives to oil. One of those is the possibility that the release of the sequestered carbon in fossil fuels is increasing the CO2 in the atmosphere and causing climate changes. A second reason for moving to these alternatives is that we have only 2% of the world's oil in this country. We use 25% of the world's oil, and we import about 2/3 of what we use. That clearly presents a huge national security risk, and we need to move to alternatives to free ourselves from so much dependence on foreign oil. And a third reason, and perhaps the best reason of all, is that the fossil fuels and the quantities we'd like to use in this aren't going to be there in the future. For a prognostication of this, I would suggest you do a Google search. It's on our website too, but do a Google search for Rickover and energy speech. the father of our nuclear submarine, gave what I think is the most insightful speech of the last century, 52 years ago, the 14th day of this May, and he predicted quite precisely where we would be today. In our desire to find these alternative fuels, we've already had 2 bubbles that have broken. By the way, the future for electricity is pretty secure. We have lots of ways of producing electricity: nuclear, wind, solar, micro hydro, true geothermal, tapping the molten core of the earth. There is no silver bullet out there for liquid fuels. And our look for that 2 bubbles, big bubbles, have already broken. The first was the hydrogen bubble. Finally, they figured out hydrogen's not an energy source, and you almost never hear anybody talking about hydrogen today. It's a great candidate for a fuel cell, of course, which is always about 20 years away. The second bubble that broke was the corn ethanol bubble, the National Academy of Sciences, and we did in our office some back-of-the-envelope computations that came to essentially the same conclusion before their report. They said if we converted all of our corn into ethanol, every bit of it, and discounted for fossil fuel input, which you ought to do. It's just silly to burn fossil fuels in another way and pretend that you're displacing them. That would displace 2.4% of our gasoline. They said that we would save more gasoline if we tuned up our car and put air in the tires. So these 2 bubbles have now broken, and there's a third bubble out there with a lot of irrational exuberance attending it, and that is the cellulosic ethanol bubble. Well, the point is that we really aren't sure what the alternative fuels of the future are going to be. Mr. Chalk, doesn't it make sense that if we don't really know what the alternative fuels of the future are going to be, but we know that they're going to have to be there for one of these 3 reasons, perhaps all 3 of the reasons I mentioned previously, that we ought to be developing flex fuel vehicles? The average car's in the fleet, what, 15, 16 years? I have no idea what the alternative fuels are going to be 16 years from now. Doesn't it make some sense to be producing these flex fuel vehicles so we'll be ready no matter what?
Well, I think it's a little bit of dilemma there. If you don't know what fuel you got to design for, it's hard to make the vehicle fuel flexible if you don't know what the fuel is. But for what we do know, we can do that. In terms of ethanol, we can go from, E15 all the way to E85 with these fuel flex vehicles.
Won't they burn methanol too? Can't we make them to burn ethanol?
I think they would have to be tuned differently, but the same technology would be suitable.
Detroit said that they could make half of all the cars flex fuel by 2012 and 80% of them by 2015. Is this a course that you could support?
Not commenting specifically on your proposal, because we don't have an administration position on it yet, but I would talk about a little bit the attributes. We have the renewable fuel standard. We have a law there on how much corn ethanol, for instance, is topped at 15 billion gallons. We have cellulosic targets, and that provides a surety to the market. I think what you're proposing would also provide surety to the market. If there was a regulation or a law that said X number of fuel flexible vehicles had to be made, that provides a level playing field for everybody. It's fairly cost effective, and we're going to need it if we're going to increase the amount of ethanol or whatever carrier we use in the gallon of gasoline. We're going to need fuel flex vehicles. There are issues, as we talked about, with California standards having a very tight evaporative emissions. We have to work that issue. So mandating fuel flex vehicles and that might include things that have high evaporative emissions, like alcohols, could be an issue. I would say we're testing right now. We have a blends testing where we're trying to see if we can go above 10% in a gallon of gasoline. And the preliminary results are very good for most highway vehicles. There are issues with smaller engines that are used for lawn and gardening and things like that. But I think, those issues can be addressed over time with phase-in and all. So having the surety of that's what the market requires, I think, is very helpful.
Mr. Chairman, if you'd permit me one more brief question. The renewable fuels standard anticipates a really pretty aggressive introduction of alternative fuels in the future. And we're now looking at cellulosic ethanol. About almost half of that billion tons that they propose to make ethanol out of comes from corn stover. The report says that we could harvest 75% of the corn stover from the fields. And the Secretary of Energy, Dr. Chu, in his testimony said that we could harvest 50% of it and be sustainable. I'm told by the Department of Agriculture that for every bushel of corn we produce in Iowa, 3 bushels of topsoil go down the Mississippi River. Now, topsoils are deep in the Midwest, and it'll take a while. But if that's true, that's not really for the long term sustainable, even with our present day agriculture, is it? Representative Woolsey and I, in the 07 Act, introduced legislation that would require sustainability studies. I'm enormously concerned about the sustainability. We drive along the road and look enviously at all of that very enviously at all that biomass out there. And for sure, for a year or two, we could rape the landscape and make some ethanol out of that. But what is this sustainability? Is your department going to focus on sustainability? Because to be realistic, we really need to know what's sustainable.
Mr. Bartlett, I'm going to preempt the question because we're well over your time at this point.
Oh, thank you.
I share the concern profoundly, but I think I want to, in respect for other members, recognize Ms. Edwards at this point.
Thank you, Mr. Chairman, and thank you to the panel. I have some questions about hydrogen. A few years ago, I was greatly enamored, about the prospects for hydrogen. I'd read Jeremy Rifkin's book. I was excited about that, about the idea that somehow we could make a huge investment into hydrogen technologies, and that would be the way to really jumpstart us in this, what he described as a new revolution, equivalent to the revolution, the Industrial Revolution in the 19th and 20th century. Since that time, and I think, Dr. Clay, you sort of spoke to this, I don't know how much real headway we've made really with hydrogen, the storage problems, the distribution problems, safety issues, et cetera. And so it makes me wonder in the FreedomCar program whether we've placed so much emphasis on hydrogen at the expense of other technologies related to vehicles. Now, there might be another question, I think, about whether we need to make investments in hydrogen technology, bringing down the cost of production at fixed sites for other kinds of power distribution, but not necessarily for vehicle use. And so I wonder if you all would be able to speak to that, and particularly as it relates to the production. I mean, I think currently now with the hydrogen production technology, it's so reliant on fossil fuels that it makes me wonder what we get for it, even if we are increasing the amounts of hydrogen that we're producing that's usable.
Thank you. Yes, I think you're bringing out some really critical points, and I think there's some interesting parallels between your question, Congresswoman, and Congressman Bartlett's questions, because it goes to this issue of the vehicle and the fuels being seen as a unit. So we need to think in a systems way about the vehicles and the fuels. So the challenges that you cite on the vehicle side, on storage, et cetera, and the resources that we've invested in trying to overcome those technologies, even if we were to solve all of those problems and break through those barriers, there are significant challenges that remain on the infrastructure side. And how we actually, even if we were to bring hydrogen fuel cell vehicles to consumers, how those consumers would be able to access convenient refueling. This is a very parallel, we can learn something from our experience with flex fuel vehicles, as Congressman Bartlett brought out, that flex fuel vehicles are now on the roadways. There are over 7 million on the roadways today, but there are fewer than 2,000 fueling stations available, where there are on the order of, I believe, 130 or 140,000 service stations for gasoline available. So we clearly have a long way to go on providing the infrastructure on the flex fuel side to make the most of that investment we've made in bringing flex fuel vehicles to the market. I think that is a cautionary tale to our continued work on hydrogen, that as we continue to invest in hydrogen technologies from the vehicle side, that we need to be working in tandem with the infrastructure side. And those two really have to be seen as a partnership.
Could I just ask you then on the production side, in terms of the relative gain around CO2 emissions, currently, are we really making gains on decreasing carbon emissions with the existing technology?
On hydrogen in particular?
On hydrogen in particular.
And this came out earlier in an earlier question. If we talk about electrifying or electrifying transport, or whether that's through batteries or fuel cells, which are still electric vehicles, we're not answering all of the challenges before us if we don't also think of decarbonizing the fuel.
The process.
The process of creating that biofuel and the life cycle implications for greenhouse gases for biofuels, and the life cycle implications for producing that hydrogen. So most of the hydrogen that's produced today is reformed from natural gas. But the beauty of hydrogen as an energy carrier is that, just like electricity, it's an energy carrier that can use a multiple number of primary fuels in its development. So right away, you've got energy diversity because you can be using both fossil fuel sources, nuclear, renewable energy, et cetera, to both provide the electricity for plug-in hybrids, but also for the electrolysis to produce the hydrogen.
Right, but our goal would be to reduce the use of the fossil fuel part of the production process, which we really haven't quite figured out yet.
Exactly right, and I think we're at the beginning of a new era where we no longer can think about the transportation and the electrical generation systems as separate. That if we think about decarbonizing, that everything that we do to decarbonize transportation has to be linked with our efforts to decarbonize electrical generation.
Great. Thank you, Mr. Chairman.
Thank you for a very interesting line of questioning, and there has been a real apparent shift in DOE's emphasis on hydrogen, and Mr. Beloga talked about this a little bit. What I'd like to do is we're approaching noon, and maybe a couple more questions from myself and maybe Mr. Inglis if he wants. Can you talk a little bit, Mr. Chalk, about that shift, about the apparent shift from hydrogen focus, why it happened, what the implications are, to somewhat follow up with Ms. Edwards?
Yeah, our hydrogen program is still robustly funded. There has been more emphasis on the plug-in hybrid electric vehicle because we feel like we can get there sooner with that technology and make a difference in terms of decreasing our dependence on oil. And obviously, as Dr. Clay just mentioned, it depends on how you get that electricity or how you get that hydrogen, whether you have a net benefit. But I would say diversity of resources is critical, and we can use fossil fuels like coal if we sequester the CO2, and that can work and provide.
Let me stay on hydrogen for a second. When you say it's robustly funded, give us a trend pattern in terms of funding levels.
Right now, it's funded at about $146 million if you look at the line item. But some of our activities have actually moved into our vehicle area. So in a way, that's mass. And what we've done is, from a system standpoint, moved our technology validation, safety and codes and standards all in our vehicle programs and be technology neutral, so to speak. But that's what pays for the hydrogen demonstration.
I haven't a clue what you just said.
Okay, well, the funding's been steady, and there's been more emphasis on the plug-in.
The funding for the hydrogen portion, and it sounded to me like you had a whole bunch of camouflage in there that I couldn't sort out. Okay. The funding for hydrogen research per se has been steady over time.
Yeah, and the budget is camouflaged a little bit because we moved some activities, and that's what I was trying to explain. But in essence, it's been fairly steady. It may have decreased a little bit, but not much.
What would your signal be to Mr. Beloga or others who've spent a great deal of investment in hydrogen research and possibly developing a hydrogen car? Do you plan to do that? I mean, I know the administration hasn't necessarily set its policy yet, but.
Well, Mr. Beloga's technology is hydrogen combustion. That is fairly well known. There's some research we could do there, but that's essentially commercial technology. The real long pole in the tent has been mentioned is hydrogen storage and fuel cell costs, and with the investments made, we made a lot of progress, and those budgets have maintained steady and actually have gone up. So we're maintaining the focus on the longer-term pathway of hydrogen, but there's been a lot more emphasis on what we can do in the next 5 years in terms of making a difference on imported oil, getting jobs out in the economy, and addressing climate change.
I've been handed a note that Ms. Edwards has a question about, what I'll do is just yield some time so you can phrase the question yourself.
Just very quickly, do you have an idea of the amount of, a comparable amount of money that the European Union has invested in hydrogen technology? Because my recollection is between $2 to $4 billion. And so when you look at the investment that we've made in comparison, I mean, are we really getting our bang for our buck?
The European investment, at least government investment, would not be nearly that high. It would be on par with what we're spending. I don't have the exact numbers. I can get back with you on the record for that.
One other question I have, and then I'll recognize Mr. Inglis. Mr. Gressler and Dr. Johnson, you talked about the need for a higher level and a sustainable level of funding. And I think, obviously, you're interested in the light and heavy-duty trucks. And I share your concern of the amount of freight that we haul in this country. I think tends to get short shrift. I think when we talk about a host of funding mechanisms, we focus on how much the weight of the truck impacts the highway maintenance side, but we seem to forget that we all eat what comes in those trucks or use it in some other fashion. What about the idea of including, we were about to look, I serve also on the Transportation Committee, and I don't know off the top of my head, I perhaps should, but to what extent highway and transit funds fund DOE's truck and car research programs, and would that be a good use of federal highway funds?
I don't know the answer to how funds would transfer between highways and DOE. I suspect that Mr. Chalk could talk more about that. What I could say is that highway infrastructure is critical to efficient freight movement, and particularly unlike light-duty vehicles where you get better MPG with downsizing, with heavy-duty vehicles you get better freight efficiency. You move more freight with less fuel by upsizing, so that the longer, heavier the trucks are, the more efficient we actually can be in moving freight. And to the extent that we can facilitate that with infrastructure, we can greatly improve. There's been many studies showing 30–40% improvement in freight movement efficiency with longer, heavier trucks that are allowed in some states today, but not allowed in all states, for example. Things like truck stop electrification, smart highways where we can have vehicles communicating and knowing, for example, if there are traffic jams to be avoided, or to time entry into a city such as to avoid a traffic jam, knowing where truck stops are available, smart navigation systems, all can substantially improve the efficiency of freight movement, and those things do get into the highway infrastructure in a significant way.
The 30 to 40% figure is pretty remarkable in light of the comments earlier about some of the research work trying to move from 41% to 47%, if I get the numbers wrong. A small percentage, fairly technical research apparently trying to move the efficiency of the engine, but if you just add a little bit of weight to the vehicle, you can get a 30% improvement in efficiency. That's an interesting question that ought to be explored. Dr. Johnson, did you care to comment on that?
Well, I think that efficiency, I in my testimony talked about gallons per payload ton mile, okay? That's why it does. If you can carry more payload, you reduce that, and it's just like trains are very efficient. And I don't have any information about the taxes and the funds, you know, between highway and DOE, but it's a good idea. There's needs to be some way to get more funds, because this sector is using a lot of energy, and and it's tough to reduce the basic efficiency of the truck. This carrying more freight then becomes a question of safety and all kinds of other issues that are in the states and locally about these long double-bottom trucks, as you probably know from your committee.
You talked earlier about the need for a steady and predictable price signal.
Right.
And I think there is a need for that. I think both for global overheating and ocean acidification issues, but also you then make the incentive, economic incentive, to do something different. I would like to see a portion of that possibly dedicated to what you're talking about here. It would make sense to me that we might want to do something like that, and possibly in the process address some of Mr. Beloga's concerns as well. Mr. Inglis.
Thank you, Mr. Chairman. By the way, that earlier reference to the elegant price signal I was talking about is something I'm working on fast and furious, is how do we internalize the externals associated with our use of fossil fuels for transportation needs and for electrical generation. If you do that, then all kinds of competing technologies become possible, because then you got a fair fight between the economics of the incumbent technology, which is gasoline and coal, compared to the economics of nuclear, which is a fabulous way to make electricity, in my view, and wind and all kinds of other things. Then you're on the market can make a decision between competitors. Right now, one competitor, fossil fuels, are getting a freebie in the air, freebie in national security, and that's not a fair fight. So as a conservative, I insist on accountability, and that means coal, be accountable for all the health consequences of what you do, and be accountable for the CO2 emissions. Liquid transportation fuels, be accountable for the national security risk we run by being dependent on a region of the world that really doesn't like us, and for all the climate issues associated with it. Then if you internalize those externals now, compare apples to apples, and suddenly all kinds of things become possible. And it's back to that very helpful point from Mr. Beloga about the premium brands suddenly become the innovation engines. So, speaking of those innovation engines, Mr. Beloga, the mini diesel that you sell in Europe, that, as I understand it, gets, 63 miles to a gallon. Why isn't that here? There's a question earlier, and maybe you could elaborate on why it's not here, or why it isn't in the U.S.
Well, California has the most stringent emission control regulations of any entity in the world. One of the things that enabled us to build diesel engines that would meet the California stringent requirements was low sulfur diesel fuel, which the EPA implemented, and fortunately now we have, which allowed us to have ultra low emissions, clean diesels we call them, on the roads. The problem that we have today with the mini diesel is a problem of getting that particular engine as clean as necessary for California. Our company has a philosophy: we don't sell only cars that meet California standards and then have dirtier cars for the rest of the country. We have only 50-state vehicles that meet California and sell them all over. So the answer to the question is because that engine family right now has to wait for the next evolution of that engine family that we're working on to get it as clean as necessary for the California requirements.
So I wonder if it's a little bit like what the chairman mentioned earlier about the Corvair. I mean, in other words, is the perfect is becoming the enemy of the good, maybe?
Perhaps, but we have to comply with the requirements, and we will certainly do so.
Right. It's sort of, I would think that, no Californians here, but I would think that on the panel, but I would think that it'd be an unintended consequence. Sort of interesting that we're passing up an opportunity right now to be driving 63 mile per gallon minis that are being sold in Europe. We're not driving because of that. It's sort of,
yes,
sort of an interesting unintended consequence, I would think, of.
Our fleet average in Europe of the BMW cars on the road in Europe is 158 grams per kilometer, which translated into mile per gallon is about 35 miles per gallon. And we attain that with about a 68% fleet of diesel cars in Europe. Now, of course, 68% or 70% of diesel cars in this country is impossible to imagine. Although there are some good signs, we're seeing that for the first time diesel fuel is actually less than regular gasoline in terms of cost. So maybe we'll make some progress with diesel cars.
Would you yield, Mr. Chairman? Do you have a calculation on the per mile CO2 emissions?
150.
In other words, so you're getting 67 miles to the gallon of diesel, but what's the net? In the end, are you getting a greater or lesser per mile CO2 emission?
The CO2 is reduced, yes it is. The CO2 is reduced because although there is more carbon in diesel fuel, you get an inherently better, approximately 30% better fuel economy. So
That's
even
my
if
question.
you get a 15 to 18% rise in carbon for the fuel, you get a 30% improvement in fuel economy, so the net is an improvement, yes.
And, Mr. Chairman, your indulgence because the time's up. I just think it's interesting that Mr. Beloga just said that the next generation may get you there on the Mini, and it's just interesting to note that BMW put in an assembly line, I think opened in 1994 in Spartanburg, and in 2006, BMW closed at Thanksgiving, paid everybody through New Year's, and ripped out a 12-year-old assembly line to replace it with a brand new one. Out with the old, in with the new. I mean, that's the kind of insistence, seems to me, that we need in public policy for getting there. You know, I mean, if you think about it, BMW likes to say they're a engineering company that happens to make cars. Well, I would just hope that Mr. Chalk takes back to the Department of Energy this kind of inspiration that says, get with it. I mean, we are in a race for the future here, and we need to have that kind of insistence. Just rip out a 12-year-old assembly line. Spend hundreds of millions of dollars to make it better. Wow, what a concept, and what an exciting inspiration, really, that I'm inspired by being with and representing companies like that. So thank you, Mr. Chairman.
And we're a legislative branch that happens to impact engineering. I thank our witnesses very much for your insightful testimony and your expertise. I thank my colleagues on the panel. And with that, unless anyone has any burning desires that we can't take up afterwards, this hearing will stand adjourned. Thank you very much.